I think that's all right, right? You can see. You've had a mild cabin life, guys. Okay, so I'm curious to see. I like to see that you were going through your study sheets and you were seeing like, do I have this stuff? Like, am I ready for this, right? So let's see here. We read this. Compass directions, just be very careful, right? You start walking and heading in that direction until point B is reached. Marks it on the GPS, keeps going in the direction north 19 west for 3.8 kilometers. Marks down a second point that's called point C, right? His distance from the second point to the car, right, is 4.7 kilometers. Calculate the total distance traveled by Mr. D. So here we go. I'm going to go south 35 west, so maybe I'll start somewhere here. And remember to always have your mini compass going with you there, north, south, east, west. So you're going south 35 west, this direction. So the 35 goes in there. Okay. And it doesn't say how far, but we get to this point and we call this point B, right? So from there, you go north 19 west. So if you want to have one of these again, you go north 19 west. So you're going in this direction. Okay, 19 goes right there. And I'm told that I'm going for 3.8 kilometers. 3.8 kilometers this leg till you get to point C. Please do not assume that you line up perfectly with the start. So I'm going to actually just cut it short right here. And then we know that from this point to the start, this is where the car is. You can call this point A maybe. We know that that distance is 4.7 kilometers. This is just interpretation. This is the story, right? And you can do some filling in. Let me zoom into that diagram here. Okay. So some assumptions we can make is that this 35 can come in here, right? Because remember, you're comparing this north-south line with this north-south line, right? These are your parallel lines. So this is the alternate interior, right? Alternate interior. So that little wedge there is 35, and you happen to have the one that's right next to it. Okay. And I cannot go over every single scenario, right? But then I will, sorry, let's do this right. Something like this, right? A, B, C, 19 and 35 add up to, what do we have, 54, right? So this is 54 degrees here. I add these two up. This is 4.7, and this is 3.8. I cannot use the 35. I can't use anything else in this scenario, right? So what are we using here? You have a pair, you see it? A pair right there. So that's sine law. That's code for sine law, right? So sine of 54 over 4.7. And the only thing you can do at this moment is solve for this angle. So I'm going to go ahead and do that. Sine of A over 3.8. Sine of A, right, is this times that. So it's cross multiply divided by what's left over. Oh, zoom out again. Okay, so that's the initial work there. So you can go A is sine inverse of this whole thing gives you 0.654 dot dot dot, right? We're going to use all decimals, and that's 40.85. That's not the end of the story just yet, right? But it's important to us because this will allow us now to find, right? Once you have this angle here, you can easily find C and then find the side across from it. Okay, so angle C is 180 minus 54 minus 40.85. I have some extras of this AC if you want to have another go at it later. So that angle is 85.15, which is also important to me, right? I think I'm going to to review, I'm going to use cosine law, okay? You can stick with sine law if you want, but I'm going to say that this angle right here is now 85.15, right? This one right here. So I have side angle side, which will allow me to solve for side C. So how does that go again? C squared is equal to 3.8 squared plus 4.7 squared minus 2 times 3.8 times 4.7 times cosine of 85.15. And I'm going to take this opportunity to remind you that if you're taking the cosine of an obtuse angle, you got to watch out because that's going to be a negative ratio, a negative decimal, which will collide with this negative, turning this whole expression positive. Only need to worry about it if you're entering this in steps, right? But my next line would be like this. I used sine law. Did I use sine law throughout? No, I did go cosine law. So if I enter this whole thing, I get 33.509, and that keeps going, which in turn gives me 5.79 kilometers. I'm still not done. So this is a heavy question, right? I get it. So total would simply be all three sides added up, right? 5.79, 3.8, 4.7. That is a total of 14.29 kilometers. That is your final answer. I probably wouldn't do something like this to you on the exam. I'll probably break it up, but you know, you should still be able to do sine law, cosine law involving compass direction. Okay. I cannot cover every scenario, but if you go through my exam review, you'll see it, right? But let's say, for instance, they had given us a different compass direction to start. Let's say this question had said you're starting west 40 degrees south, right? So it'd be west 40 degrees south to get to point B. The 40 would go in there, okay? And then you would go, I would tell you, hey, you're going north 19, let's say. Still 19 here, the same as before, right? North 19 degrees west. And then you close this. Be careful closing this. Just do a soft line, okay? That 40 here, guys, remember, you have the same compass rose here as well. And now the parallel lines would be this one and this one, okay? So where does the 40 go? Not here, right? It kind of crosses that transversal, you remember that? So the 40 would actually go there. And you just have to do a little trick here. You know that there's a 90 here, correct? Too early in the morning or what? So this is a 50. So now that will allow you to find the angle inside the triangle. Okay, so you have to be very careful not to think it's always going to be the same, right? So you have to find your parallel lines. Where does that angle that I'm given? And this 40 is not part of the triangle, right? Because it actually gets cut here, but it will help us to figure out stuff on this angle right here. Okay. That's that. Let's do the story here. This is a quadratic, right? Chip is camping at Tullaby Falls, cliff diving from the highest point, 20 feet above water. Since he jumps up just before leaving the top of the cliff, he reaches a maximum height. Determine the quadratic equation. So you don't have to give me a fancy graph because I'm not asking for it, but I do want 3 points, right? So this would be time and height. And so you're going like this, you're jumping off the cliff. and hitting the water, right? So this is 0, 20, right? That's at time 0, you're at 20. The vertex is given to you. You have to just watch out. You put the right number in the right place, in the right order. And do not be tempted to find this one, right? You kind of just have to go say, okay, if I get to this point, I'm coming back to it at some point here. Okay. So I'm getting back to 20. It took me 0.82 seconds to get to the highest point, so it'll take twice as long to get back to this. Okay. So that's 1.64 is that's the most important point out of this whole operation. Okay. If you want to have time and height like this, because remember, you always need 3 points. It's 4, 20, and this goes into L1, L2, and stat, calc, quadreg. I would encourage you to go quadreg because in grade 12, this will not always be quadreg. Okay, not always be a quadratic. You type that in. Do you remember how to do that? Maybe I forgot how to do that even. Okay, so stat, enter, clear, 0. Enter that there, 20, 24, 20. Let's see here. If I just go ahead and figure out the quadratic regression, it's L1, comma, L2, comma, vars, y vars, enter, enter, enter. There it is, negative 5.95 x squared plus 9.76 x plus 20. And that would be the quadratic equation modeling this scenario. And then I can ask you a bunch of other questions based on that. So this is all A, right? We're done there. B, how high was chip after 1.8 seconds? That's the X value that you're given. So we're going to go second trace 1 and let X be, which is time, 1.8. So let's see if we can graph this thing. Okay. So we got a couple of options. What did I'm trying to remember how I did this with you. I think you can turn on plot 1 if you'd like, because you used L1 and L2, right? And that allows you to use zoom 9, zoom stat, right? And there it'll show you those 3 points for sure. But we need to adjust our window, right? So I'm going to make sure I go -1 for the X. I'm going to go maybe 2 or 3 out in the X, but with the X values. Y min, I'm going to go just under, and Y max is probably good to go 25. Okay. And remember, this is a word problem, so we only consider quadrant 1. So second trace 1, 1.8, and there it is. It's 18.29. 18y is 18.29, and just use the units that are in this question, which is feet, right? Just go feet there. What is the domain of this situation? I don't know why I didn't ask for range, but the domain would be the x values, acceptable x values, right? So it starts at time 0, and it will end when you hit the water, right? In this case. So we need to find that x-intercept. Let y2 be 0, graph that, and then we go second trace 5, get a little closer to that one there, enter, enter, enter. So it's 2.83, 2.83. So I'll show that work here. The x-intercept, let y2 equals 0, and then second trace 5, and that is 2.820. Okay. 2.820. So this point right there is actually my x-intercept right there. So time goes from 0 to that point, square brackets, and the range goes from 0, that's the lowest the y values can get, all the way to the highest, which is 24. It didn't ask for it, but it doesn't hurt knowing how to do that. This is a blast from the past, right? Backside. Let's see how that went. Start somewhere. Can you please tell me which one you start with? Even on the exam, just at least. I would prefer if you tell me exactly which route you take. I'm trying to think here. What am I going to do? Where am I going to start? I think I'm going to start with this one going. I think I need to be careful here. What I will do is I will take this 58 and just show that I'm bringing that over here. 58, and that's alternate interior, right, angles. I've got that. This 86, I can actually, if I look at it, it's a parallelogram. So this side is the same, is parallel to that side. And this side is parallel to that side. Okay, so there's a bunch of parallel lines here. So in this case, because it's a parallelogram, things change a little bit. But I can actually say that this 86 can transfer over to X because these are two parallel lines and they're connected by this transversal. So I can start with that, right? So I know that this is 86. 86 degrees Y. Alternate interior angles are congruent. And I will ask you perhaps to only use one justification. You can only use it once, all right? So be careful with that. So this is now 86. To get Y, it's all along this here. So I'm just going to go, I just went 180 minus 58 minus 86. You just show me your math there. That's 36. And I will just call that straight angle is equal to 180 degrees, right? This straight angle down here, all three of these need to add up to 180, right? So that's 36 right there. How can we figure out A? We can actually use sum of triangle if you want. So how about we do that? So I'm going to go 180 minus 86 minus 58. And that is 36 as well, right? Sum of triangle is equal to 180. So I got this is 36 here, and this is 36 as well. And Z is the last one, is up here. I used straight angle already, right? What else can I use here? This is my transversal connecting them. I think I'm stuck with straight angle there. That's okay. So I'm going to go 180 minus 86 minus 36, and that gives me 58. So 58 degrees there. Straight angle is equal to 180. Okay. Running out of time here, but here it is. For something like this, what's the first thing you need to find when it's a polygon? Find the interior, well, number of sides. Yes, that's right. Number of sides, and then find the interior angles of that thing, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So n is equal to 12. X x is the interior angle, right? This one here. So I'm just going to say that the interior angle is n minus 2 times 180 divided by n. So that would be n minus 2, right? 12 minus 2 times 180 divided by 12, which is 10 times 180 divided by 12, which is 150 degrees. Okay, so you would get a mark there immediately. What's Z? It's the last letter in the alphabet, Mr. Dirks. But in this case, right, this is your interior and this is the exterior, right? Interior, exterior. They always add up to 180. So you can either do this formula, which is 360 divided by n, which is 30 degrees, right? Or you could have just used this fact, right? The exterior would be 180 minus the interior. The exterior is 180 minus 150, which is 30 degrees. Okay. So you got that. And next we have to find y. And that's when you just focus in on this one here. Right, that is an isosceles 1, 2, 3, 4, 5, an isosceles pentagon. So that is actually, if you look up y, it's going to be 540 minus, there are 3 interior angles you need to subtract. 3 of the 150s you need to subtract from it. So 3 times 150 divided by 2. So what's happening is that you know that this is 540. All the interior angles added up is 540. Take away the 3 150s and then split that remainder in half. And this is 90 here divided by 2. So y is equal to 45 degrees. That's how you do one of those. Inscribed, they're called. Inscribed polygons. And to finish the day today, this one should be a slam dunk, guys. This is, if it's a diagram, please make sure. This is a what? Side angle side, right? You have no pair. So it's asking, oh, solving the triangle. Okay, so the first thing we need to do is find side F here. I'm going to do that over here. So F squared is equal to 105.7 squared plus 78.9 squared. I'm going to run out of room. That's what it is. F is square root of 103.48.65 dot dot dot. F ends up being 101.73. We are in meters. So that is part of your work there. And now you can switch over to whatever you want. Because you have a pair, you could use sine of 65 over the side you just found, right? And solve for any of the other angles. What did I do? I think I went sine of D, so I tried to solve this, put that other side underneath it. Sine of D is 78.9 times sine of 65 divided by 101.73. Sine of D is 0. My key doesn't show that right now, but I'm just going to tell you that angle D eventually is 44.66 degrees, which in turn helps you find E, which is 70.34 degrees. I'm just going to give you the answers there. This is sum of triangles is equal to 180, right? That's what I used to come up with E. That's it for today, guys. Tomorrow, I think I'm going to review the quadratic formula. How do you use the quadratic formula? It's going to be something like that on the exam. I'm going to review to figure out how many triangles are there if it's an SSA scenario. If it's an ambiguous case. And just wrap things up one last time. Maybe talk a little bit about the statistics part.